This was a paper that we published just a few weeks ago. There was a kind of sense that perhaps limiting warming to 1.5 will solve a lot of the problems in terms of climate impacts. But our clear conclusion from a kind of synthesis of all of the available evidence is that it's probably too high. In fact, I would say it's certainly too high for polar ice sheets. So my key conclusion in my first bullet point here is that limiting warming to 1.5 is essential, but it will not slow sea level rise from melting ice sheets, which, as I said, store around 65 meters of sea level equivalent. So even if they just lost 10% of their mass, just thinking back to Harry's talk there, even if they lost just 10% of their mass, that would be 6.5 meters of sea level rise. What we know is that even under current warming of 1.2 degrees, that sea level rise is accelerating. There's a recent paper published just a few months towards the end of last year showing that the rate of acceleration of sea level rise the rate of sea level rise has doubled. It's currently rising at 4.5 millimeters per year. But if we just take that current rate of acceleration throughout the rest of this century, then we reach rates of 1 centimeter per year before the end of this century. And as I said to my children back in Durham recently, they should keep hold of this paper and see if that is actually borne out within their lifetimes, because we often think of sea level rise as something very distant, something that's happening in the future. This is happening now, and the rates of acceleration are alarming. If we look back at what's contributed to sea level rise, thermal expansion of the ocean waters has been one of the dominant causes. The ocean warms and it expands. Melting of the smaller mountain glaciers and ice sheets has also dominated the contribution over the last few decades. But what we're seeing now is a quite dramatic decline in the ice sheets in Greenland and Antarctica. And they are now, for the first time in the last year or two, seem to have overtaken the mountain glaciers in terms of their sea level contribution. So if we look at this plot, this is a plot of satellite data that actually measures very accurately the mass gains and the mass losses of the ice sheet. So everything that you can see on this plot, the thin lines are the East Antarctic ice sheet in black, which actually stores over 50 meters of sea level equivalent. The West Antarctic ice sheet is the red line, and the Greenland ice sheet is in turquoise. And any of the line that's below the zero, the dashed line along the center of that plot, means it's contributing to sea level. You might notice that you can see for East Antarctica in the last couple of years, we had some very, very heavy snowfall events. That was misreported in the media as the Antarctic ice sheet growing, so I just want to correct that misconception. It's not growing. They were short-term weather events, but overall, the Antarctic contribution to sea level rise is certainly positive in terms of its adding to sea level rise. The most important line on this graph is actually the dark blue line, because that's the cumulative sea level rise that's been caused by the ice sheets over the last few decades. And you can see they've added nearly 25 millimeters to global mean sea level. They're actually adding about 370 billion tons of ice each year into the global oceans. So we looked in this paper at the current observations of mass balance, and it paints a very dramatic picture. Some of these rates of mass loss exceed what we thought was the worst case scenario just a few years ago. The other thing we did in this paper was we looked at how the ice sheets responded during past warm periods and what kinds of sea levels were attained. And what's very clear from this table, and I'll just zoom in on a couple of important numbers in a second, is that we should expect several meters of sea level rise over the coming centuries. It's very clear if you go back through the IPCC reports that multiple meters, 2 to 9 meters, 5 to 9 meters, is locked in already over millennial timescales. And we used to think that this would take 1,000, 2,000 years. We now know that that's almost certainly incorrect, and that things are happening far more quickly than previously thought. So just to highlight here, if we look at the forcings in the top row, the last time the Earth was kind of as warm as today, actually slightly cooler if you look at the numbers, then we got sea level rise of about 2 to 9 meters. And that's very worrying. That was obviously a natural warm period caused by the way the Earth orbits the sun. If we go back a bit further in time to about 400,000 years ago, we had another warm period. Again, CO2 levels much, much lower than present. Global mean temperatures between 1, possibly 2 degrees, and we get 6 to 13 meters of sea level rise. And then finally, if we go back to the mid-Pliocene, about 3 million years ago, those CO2 levels and the temperatures are kind of comparable to where we might be going in the next century or so. And you can see there that global mean sea level is 10 to 20 meters high. This is not complicated science. This is very simple physics that if you warm planet Earth, you lose mass and you increase sea level. And actually, just as I was preparing the talk, a new paper came out in the last week or so showing what they did is they modeled the ice sheet over the last 800,000 years. And what was quite startling in these results was that it was very consistent with our message that actually current warming, perhaps a slight degree of ocean warming, just a quarter of a degree above present, causes almost complete collapse of the West Antarctic ice sheet and generates about 4 meters of sea level rise. So when you run their animation, the black dot, the dots there on the blue line are showing you the ocean temperatures, and the 0 line is kind of present day. And so what you see as we hit those red circles is when the ocean just gets a little bit warmer than present. And you see complete collapse of the West Antarctic ice sheet, which as you look at it is on the left-hand side of the graph. So there's a really clear and consistent message from this study that if we hold current ocean conditions as they are or just increase them very slightly, we are committing ourselves to losing the West Antarctic ice sheet and adding about 4 meters to sea level rise. And this is very consistent behavior. And then finally, the third piece of evidence we looked at in this study was actually computer simulations of the future sea level contribution from both the ice sheets in Greenland and Antarctica. And most computer simulations show that 1.5 degree will not slow sea level rise. As I said at the very beginning, there's a sense sometimes that 1.5 will solve our problems, but that is not the case. With sea level rise from ice sheets, we are committing ourselves, even at current warming levels, to several meters of sea level rise relatively quickly. This plot is just from Antarctica. It shows what's possible just from Antarctica at a 1.5 degree scenario. We're looking at over 1.5 meters, that mid-range, the black line, over the next few centuries. And this is very, very concerning. There are other studies out there. There's a growing number of studies showing that current warming is sufficient to trigger collapse that is irreversible on human timescales. We can get rid of these ice sheets very quickly. It takes a much, much longer time to regrow them. So to finish, these are my conclusions. Limiting warming to 1.5 is essential, but the best case scenario is that sea level rise is slow and steady. And by that, I mean kind of less than 10 millimeters a year would be manageable potentially. If we exceed 10 millimeters per year, then I think that starts to become something that's very challenging to adapt to. And we know that ice sheets are losing mass at 1.2 degrees, which is where we are at the moment, and that actually we would hit that 10 millimeters a year before the end of this century. So every fraction of a degree really, really matters for ice sheets. Tiny change in temperature cause multi-meter increases in sea level. And to slow sea level rise from ice sheets to a manageable level requires a long-term temperature goal, clearly, that is closer to 1 degree, certainly has to be cooler than present. And so the sooner that we can slow and stop the warming, the easier it will be to return to those safe levels in the future. Thank you.